Well, here's a fun question for you. Could black holes actually be wormholes? In other words, what if black holes are secret doorways to other parts of the universe? And if you fall into one, you get teleported into another galaxy, just like in sci-fi movies. Well, let's see if that could work. Black holes are incredibly heavy and dense celestial objects. They're like whirlpools in a bathtub, but on a space scale. Everything that gets too close to them, including planets, stars, and even light itself, gets sucked in, and nothing can get out. They're born when a big star gets super old and eventually collapses onto itself, leaving behind a small super-dense core. If this core is massive enough, it becomes so powerful that gravity takes over everything and we get a black hole. Black holes, despite the name, are not at all empty. Instead, it's like having a giant amount of stuff squeezed into a very tiny space. Picture a star way bigger than our Sun, packed into a sphere about the size of New York City. This creates such a strong pull of gravity that absolutely nothing can escape from it. NASA has been using special tools to learn more about these weird things. Since they're, well, black, we just can't find them by looking at telescopes. But we can figure out that they're there by watching how they affect other stuff nearby. For example, when a black hole moves close to some space dust, it sucks the dust in. This process is called accretion. It's kind of like when you vacuum up dirt. When this happens, the matter speeds up and gets super hot, emitting X-rays that we can see. Okay, now that we know what black holes are, let's talk about wormholes. Imagine a wormhole as a tunnel in space that could let us travel quickly to faraway places in the universe. They connect two different points in space as if it were a sheet of paper that can be bent in half. Basically, they're intergalactic teleports. This idea comes from Einstein's theory of relativity and involves folding space and time. In the early 1900s, he and others thought about the possibility of these shortcuts and called them wormholes. So far, we don't know if they exist. We see them in sci-fi movies often, looking like a big round opening. But the problem is, if they're real, they could be incredibly tiny, smaller than even a grain of sand, and they might not last long, collapsing before we could even use them. To make matters even more complicated, you need a special kind of matter, which we haven't seen in the universe yet, to keep the wormhole stable. Regular matter won't do the trick. And even if we could find and create a big wormhole and make it stable, it's not clear if humans could travel through it. Some scientists think the law of physics might not allow it. But just maybe, in the future, with incredibly advanced technology, we could figure out how to use these space tunnels for travel. Until then, wormholes are mostly in the realm of imagination. So, could one thing be another? Some scientists think that it might be possible. A team of researchers from Sofia University in Bulgaria suggests that some black holes might be wormholes. The biggest question for scientists is, where does all this stuff that falls into a black hole go? And here's where they introduce the idea of something called a white hole. Well, as you can guess, it's like the opposite of a black hole. Instead of pulling things in, it constantly pushes them away. If we looked at one, it would look like a super bright fountain that constantly spews out matter and energy. Just like regular black holes, they should have properties like mass, charge, and how they spin. They pull things toward them because of gravity. But if something fell towards a white hole, it would never actually reach it. This is because they don't have a surface like the ground we walk on. Instead, their gravity gets stronger and stronger, but there's no surface to land on. As we mentioned before, scientists believe that supermassive black holes are at the center of every galaxy. Some have suggested that they might give birth to supermassive white holes. However, this is just a theory and not proven. The idea of white holes was first suggested in the 1960s as one of the solutions to Einstein's equations. This solution describes a black hole that lasts forever from the viewpoint of someone inside it. But black holes are formed when massive stars collapse, so they have a different structure. So now, imagine if these black holes and white holes were connected, forming some sort of space tunnel. One end of this tunnel sucks everything in, and the other pushes everything out. Well, guess what it would be called? However, this wormhole wouldn't be as cool as it sounds. Just like regular wormholes, these ones would be super fragile, like a very stretched rubber band that snaps easily. Researchers believe that, if that's the case, these wormholes might look remarkably similar to the black holes we already know about. In fact, they say it's incredibly tricky to tell the difference. The light and radiation coming from the swirling matter around a black hole could be the same as what we'd see around a wormhole. So for now, all of this is purely theoretical. To see if they're right, we'd have to prove the existence of white holes themselves. But hey, while we're at it, let's dive into another hypothetical scenario. What happens when we bump a wormhole and a black hole into each other? Ooh, what fun! Scientists think they might spot this unusual event by looking for something called gravitational waves. These waves are like ripple in the fabric of space and time, caused by massive things moving around. And as we all know, black holes are the heaviest things around. Imagine that you have a spinning top on the surface of the water. If you spin it slowly, waves that come from it would have a larger, lower frequency. And if you start spinning it very quickly, the waves around it will be very frequent. This is exactly what happens when a heavy object dances in space. Black holes create gravitational waves as they spin. And the faster they do that, the higher the pitch of the sound they make. In space, this sound is like a chirping noise. So, picture a black hole falling into a wormhole. At first, you'd hear a chirp as it approaches the wormhole. While a black hole circles around, it would create another interesting pattern of gravitational waves. But when it gets sucked in and reaches the center of the wormhole, the waves suddenly stop in one part of the universe. And as it comes out the other side, the chirping would change into an anti-chirp. They would appear and disappear as the black hole goes in and out of the wormhole. This pattern would repeat as the black hole goes back and forth. As the black hole keeps bouncing between these two parts of the universe, it would produce bursts of gravitational waves followed by silence. Now, if scientists detect these unique gravitational wave patterns, it could be a clue that wormholes really exist. This unique chirp and anti-chirp could be a clue that a black hole has fallen into a wormhole. But that's just the theory, since wormholes are very speculative and still a big mystery in science. So while this idea is cool and could help prove the existence of wormholes, it's still a big maybe. In any case, we'll need some super advanced telescopes or very clever tricks to tell the two apart and see if wormholes are real at all. But until then, it's all a fascinating mystery. And truthfully, I'd rather not fling myself into a black hole to find out.
Woohoo! When astronomers started a project that was organized to create a detailed 3D map of our galaxy, they didn't expect to find anything surprising. But that's exactly what happened. Earlier in that year, Harvard scientist Dr. Anna Bonacca noticed a weird disturbance in our galaxy's stellar streams. A stellar stream is a line of stars that are moving together through galaxies. The stellar stream we're talking about is called GD1, and it's stretched in an impressive line across our sky. This stream used to be a cohesive line, stretched by the gravity of our galaxy. One day, Dr. Bonacca noticed a gap in it, and this gap had a strange, ragged edge. In fact, it looked like something terrifyingly huge recently plunged through the stellar stream. The sheer force of this object's gravity was so great that it managed to drag stars in its wake. The most shocking thing was that the telescopes simply failed to find the source of the damage. But then, what could this unseen bullet be? One theory suggests that the intruder is a stray star. But, according to Dr. Bonacca, The hole is way bigger than any existing star. It'd have to be 1,000,000 times more massive than our Sun. Okay, so what if the hole in the Milky Way was torn by a supermassive black hole, like the one that dwells in the center of our galaxy? If these two black holes got too close, they wouldn't be able to escape each other's gravity. A collision might be inevitable. Then the stronger of the two holes would consume the weaker one, and one huge, super mighty black hole would appear. But people have yet to witness a collision of black holes. Plus, scientists can't predict the consequences of such a merge, even though they've simulated it on powerful computers. The only obvious fact is that it would produce incredible amounts of energy. Huge ripples would travel through the entire universe, bound to hit our planet eventually. Then again, two black holes in one galaxy might refuse to merge. Imagine this. A supermassive black hole hundreds of millions of times the mass of the Sun is spinning in the center of the Milky Way at a phenomenal speed. Another spinning black hole approaches ours. What do you think will happen? Right, one of the holes, most likely the intruder, will get kicked out and sent hurtling away like a frisbee flying through space. And who can guarantee that it wouldn't head toward the Earth? Luckily for us, there aren't any supermassive black holes in the vicinity, so this theory fails to explain the mysterious bullet hole phenomenon. Dr. Bonacca still doesn't rule out the possibility that the intruder is some kind of luminous, star-like object. After tearing a hole in the Milky Way, it could be hiding somewhere in the galaxy. But again, it seems highly unlikely because of the object's huge size. I mean, we're talking 30 to 65 light-years across. In any case, it's hard to predict where it would have ended up if it were a luminous object. The intruder could have been moving at an incredibly high speed and wouldn't have to be very massive to tear a hole in the stellar stream. Or it could have been moving more slowly, but be very heavy. But the astronomers don't know which option it was. That's why it's next to impossible to predict where it ended up.
When a team of astronomers embarked on an ambitious project to craft a comprehensive 3D depiction of our galaxy, they anticipated standard findings. Yet, they stumbled upon something completely unexpected. Dr. Anna Bonacca, a distinguished scientist from Harvard, detected an unusual interference in the stellar streams of our galaxy. These stellar streams are essentially pathways of stars that traverse galaxies in unison. The specific stream in focus, named GD1, spans a remarkable distance across our celestial canvas. Historically, this stream maintained a consistent line, molded by the galaxy's gravitational pull. However, Dr. Bonacca observed an anomaly, a gap with an irregular outline. It appeared as though a massive entity had recently burst through GD1, its gravitational prowess pulling stars along its path. Intriguingly, telescopes couldn't pinpoint what caused this disruption. The burning question then was, what could this invisible force possibly be? I hope this unknowable force doesn't stop you from clicking the subscribe button, giving it a like, and hitting the bell. Your support is very important. Thank you. There's a hypothesis that an unfamiliar star could be the culprit. However, Dr. Bonacca believes that the size of this disturbance is much larger than any known star. It would need to be a staggering 1,000,000 times the mass of our Sun. But let's consider another possibility. What if a gargantuan black hole, akin to the one at our galaxy's core, caused this disruption in the Milky Way? If two such black holes neared each other, they might get trapped in their mutual gravitational pull, leading to a potential catastrophic collision. Then, the stronger of the two holes would consume the weaker one, and one huge super-mighty black hole would appear. But people have yet to witness a collision of black holes. Plus, scientists can't predict the consequences of such a merge, even though they've simulated it on powerful computers. The only obvious fact is that it would produce incredible amounts of energy. Huge ripples would travel through the entire universe, bound to hit our planet eventually. Then again, two black holes in one galaxy might refuse to merge. Imagine this. A supermassive black hole hundreds of millions of times the mass of the Sun is spinning in the center of the Milky Way at a phenomenal speed. Another spinning black hole approaches ours. What do you think will happen? Right. One of the holes, most likely the intruder, will get kicked out and sent hurtling away like a frisbee flying through space. And who can guarantee that it wouldn't head toward the Earth? Luckily for us, there aren't any supermassive black holes in the vicinity, so this theory fails to explain the mysterious bullet hole phenomenon. Dr. Bonica still doesn't rule out the possibility that the intruder is some kind of luminous, star-like object. After tearing a hole in the Milky Way, it could be hiding somewhere in the galaxy. But again, it seems highly unlikely because of the object's huge size. I mean, we're talking 30 to 65 light-years across. In any case, predicting the location of this mysterious intruder is as challenging as guessing where your missing sock disappears to after laundry day. Speaking of things disappearing, don't let this channel vanish from your feed. Hit that subscribe button. The intruder could have been blazing fast, requiring minimal mass to cause such a disturbance in the stellar stream, or it could have been a slower, massive behemoth. Astronomers are still scratching their heads, which just goes to show that some mysteries are harder to unravel than others.
It was the year 2017 when astronomers spotted a bright star hurtling out of the Milky Way. It was moving incredibly fast at a speed of 2 million miles per hour. That's almost 4 times as fast as the Sun orbits around the center of our home Milky Way galaxy. It takes our star more than 225 million years to complete one journey. Anyway, back to our star, the Wanderer. The main issue with it was that it was moving against the direction in which most stars travel around the center of our galaxy. Even more bizarre, it consisted of totally different star stuff. Astronomers managed to identify its composition. The star was made up of heavy metallic atoms. At the same time, most of the other stars consist of way lighter elements. The wandering star got the name LP-40-365. It was moving so fast that it literally dashed out of our galaxy. This made scientists believe that the space traveler was pushed out of its place by some kind of cosmic disaster, like a supernova. A supernova is the largest explosion that can take place in space, an explosion of a star. It happens after irreversible changes start in the core of a star. Supernovas can occur in 2 ways: in binary star systems and when there's a single star. Binary stars are 2 stars orbiting around the same center. At some moment, one of the stars, a very dense white dwarf, starts stealing matter from its companion. After some time, this thief accumulates too much matter, which causes it to explode into a supernova. Or it can be a single star nearing the end of its life. It's running out of its fuel. More and more mass is flowing into the core of the star. In the end, the core becomes so heavy that it fails to withstand its own gravity. After the core collapses, a tremendous amount of energy is released in a supernova. But astronomers still can't figure out how a supernova could send LP-40-365 flying. There are more questions than answers. Was it a companion star that got flung out by a shockwave created by a supernova? Or was it a piece of the exploded star? A new study based on the collected data has shown that the star, which is a white dwarf, keeps slowly rotating around its axis. Astronomers are almost sure it means LP-40-365 is indeed just a chunk of space debris, and not a full-fledged star. This wandering piece somehow managed to survive one of the fiercest space events. But after making such a conclusion, scientists realize something amazing. LP-40-365's unusual features could appear after the star witnessed a supernova. Even though this event happened lightning fast, the entire makeup of the star got changed. Most stars consist mainly of helium and hydrogen, but LP-40-365 is different. It contains such heavy elements as magnesium, oxygen, and neon. It must have been the supernova that added these atoms to the star's composition. By the way, astronomers consider all elements that are heavier than helium to be metals. This means that after witnessing the supernova, LP-40-365 became metallic. Right now, the star doesn't have its own planets, but NASA's Transiting Exoplanet Survey satellite, which is on the lookout for distant planets passing in front of their host stars and dimming them, has noticed a curious thing. LP-40-365 brightens and then dims again every 8.9 hours. It might mean that the star pulsates, but usually stellar pulsations are much less regular. A more plausible explanation is that the star's surface is uneven, and as it spins, sunspots are brought into and out of view. And it's great news, because after astronomers figure out how fast the star rotates, they can understand what happened to it around 5 million years ago during the supernova. Bright blue exoplanet HD 189733b looks peaceful and eerily familiar. Doesn't it resemble Earth? But this appearance conceals the planet's terrifying nature. There, the winds blow at 5,400 miles per hour. It's 7 times the speed of sound. But that's not the worst. It rains glass, sideways, in this scorching hot world. Neutron stars are ultra-dense collapsed cores of giant stars. They emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. The most plausible theory is that this signal was probably produced by a disk of dust surrounding the star. But there isn't enough evidence to confirm this idea. Mercury is the fastest planet in the solar system. It zips around the sun at a breakneck speed of more than 100,000 miles per hour. That's around 40,000 miles per hour faster than our home planet. It's one of the reasons why a year on Mercury equals 88 days on Earth. Mercury is the planet that orbits the closest to the sun. That's why if you were standing on its surface at its closest approach to our star, the sun would look more than 3 times as large as it does on Earth. The Black Widow pulsar is a rotating neutron star that is munching on its partner, which is a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. There's a stellar nursery in the constellation Centaurus, and even though this place is called a nursery, it's anything but peaceful or safe. It's made up of hydrogen and newborn stars and is located in a nebula around 6,500 light-years away from Earth. A nebula is a giant cloud of gas and dust floating in space. The intense energy baby stars emit makes hydrogen clouds glow ominous red. This energy is so powerful, it's eating away dark clouds of dust. Astronomers can see them disappear like lumps of butter on a hot frying pan. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice, and this ice is burning. The planet completes one full orbit around the red dwarf Gliese 436 in just 2 days. It means the exoplanet travels very close to its parent star. That might be the reason why the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet hosts huge volumes of water ice known as Ice X. And this ice remains solid despite such incredibly high temperatures. Jupiter is the largest planet in the solar system. It's 318 times as massive as Earth. It's also 2.5 times as massive as all other planets of the solar system combined. But here's a paradox. If this gas giant got even more massive, it'd actually become smaller. The added mass would make the planet denser, and this would cause it to start pulling in on itself. Astronomers claim that Jupiter can eventually end up being 4 times as massive as it is now. But at the same time, its size won't change. JWST galaxy is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thin. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind. Those are usually found in clusters. It can mean that JWST was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Saturn's moon, Hyperion, is one of the most bizarre-looking moons in the solar system. But the appearance isn't the strangest thing about this space body. The pumice stone-like rock is pockmarked with countless craters, and it's also charged with static electricity, which is flowing out into space. About 4,000 light-years away from Earth, there's a planet that seems to be one enormous diamond. The planet is denser than any other discovered so far and consists mostly of carbon. It's so dense that astronomers think this carbon might be crystalline. It means that at least some part of the planet is diamond. Ceres is the most massive space body in the asteroid belt between Jupiter and Mars. It totals almost a third of the entire mass of the whole belt. But at the same time, Ceres is the tiniest of the dwarf planets out there. It's also the only dwarf planet that dwells in the asteroid belt, and also the only one that is located in the inner solar system. Astronomers sometimes call Jupiter a failed star. The gas giant indeed contains a lot of helium and hydrogen. But its mass isn't enough to start a fusion reaction in its core. And that's exactly how stars produce energy. They fuse the atoms of hydrogen together under extreme pressure and heat and create helium. In the process, they also release light and heat. Jupiter could start a nuclear reaction and become a star only if it was 70 times its current mass. Space is completely, eerily silent. That's because in the vacuum of space, there's no atmosphere, and the sound waves need some medium to travel through. That's why worlds with atmospheres like Earth are full of noise. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have enough mass of 1,000 sedans. One theory claims that tons of micro-black holes could be created right after the Big Bang. Some scientists even go so far as to say that a couple of mini black holes pass through our planet every day. Every hour, the sun sends more energy to Earth than our planet uses in a year. Even though people are now using much more solar energy than a decade ago, it's still a mere 0.7% of the world's annual electricity usage. There might be moons orbiting other moons, but astronomers haven't agreed on this theory yet. Planets orbit stars, moons orbit planets. But why can't there be moons, also known as submoons, moonettes, and moons? Researchers claim that moons could exist, but the host moon has to be massive enough and the moon small enough. There must also be a large distance between these moons and the host planet. Jupiter is the most massive planet in the solar system. This means its gravity is also the most intense. It's 2.5 times as great as what we have on our home planet. Once, the gas giant's gravity even tore apart a large comet called Comet Shoemaker-Levy 9. Then the planet eagerly swallowed the chunks of the former comet. If you were standing at the equator on Mars, the temperature at your feet would feel like that of a warm spring day, but your head would be literally freezing. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars, but one of them, floating 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates never-ending flashing auroras in the planet's atmosphere. Europa is one of Jupiter's largest moons, even though it's smaller than Earth's moon. But the cool thing about this satellite of the gas giant is that it's covered with ice. And some of this ice is smooth, which means you could skate there. And a 3-foot axle jump you can perform on our planet would take you 22 feet into the air. At the same time, the landing speed on Europa would be the same as it is on Earth. Haumea, a dwarf planet orbiting the Kuiper Belt, has a bizarre elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning large object in the solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile-wide ring circling it. Astronomers haven't managed to figure out how or why it appeared around the dwarf planet. 11 Earths could fit across the equator of Jupiter, and if our planet was the size of a grape, the gas giant would be as large as a basketball. 9 spacecraft have already visited Jupiter. 7 of them just flew by, and 2 orbited the huge planet. The most recent of them, Juno, arrived at Jupiter in 2016. The craters of the moon's south pole are likely to be the frostiest place in the whole solar system. The crater's floors are always in the shadow. That's why the temperature never rises above 397 degrees Fahrenheit, even during the day. If you decided to fly a plane to Pluto, your journey would take around 800 years. You'll find the highest mountain in the solar system on an asteroid called Vesta. Its peak rises 14 miles above the base of the mountain. This makes Rye Sylvia, that's what the mountain is called, almost 3 times taller than Everest. Saturn's rings weren't discovered all at once. It happened gradually. That's why they were named alphabetically in the order scientists found them. Now they go like this: D, C, B, A, F, G, and E. A day on Venus is around 243 Earth days long. But the bad news is that you'd have to wait for a weekend for 3 years. All because a day on Venus is longer than its year. A solar phenomenon called terminator events is taking place at the Sun's equator. Disastrous magnetic field collisions seem to cause ginormous twin tsunamis of plasma. These tsunamis tear across the star's surface, moving at a speed of 1,000 feet per second. They can last for weeks at a time and happen almost every decade. The winds on Neptune are the fastest in our solar system. Most of them can reach the speed of 1,600 miles per hour. Almost any of these enormous storms could easily swallow our entire planet. The 18th brightest star in the night sky, Fomalhaut, is a terrifying sight. It's dubbed the Eye of Sauron because a ring of dust and debris circling it makes it look like a giant eye staring into your soul. The intimidating star is more than twice the mass of our Sun and is 25 light-years away from Earth, which isn't that far away considering distances in space. Mars has 2 moons, Phobos and Deimos. In the next 30 to 50 million years, the planet's gravitational forces will tear Phobos apart. It'll probably result in the formation of a ring around Mars. An asteroid the size of a car enters the atmosphere of our planet every year. Such an intruder could wipe out a small town off the face of the Earth. Dust and smoke would rise into the atmosphere, preventing sunlight from reaching the surface of the planet. It would cause the temperatures all over the world to drop and the climate would change. Luckily, such asteroids burn in the atmosphere before they even come close to the surface. The radio signal produced by a spacecraft when it contacts Earth is less powerful than a light bulb in your fridge. By the time this signal reaches our planet, its power is only 1/1000th of a watt. No wonder that antennas gathering these super weak signals are huge. The Deep Space Network that detects signals from spacecraft has dish antennas that measure up to 230 feet across. That's more than the width of a soccer field. In 1999, NASA lost a Mars orbiter because one engineering team was using the metric system, and another was doing calculations with the help of the imperial system. Nebulas are giant clouds of gas and dust. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger. And their gravity gets more powerful. One day, a nebula's mass becomes so great that it collapses under its own gravity and forms a new star. Around 4,000 light-years away, in the constellation of Scorpion, there is the Butterfly Nebula. Its wingspan is greater than 3 light-years, and the structure inside the nebula is one of the most complicated ever observed. The nebula's central star, a white dwarf, is heated to an insane 450,000 degrees Fahrenheit. This means it was formed from another huge star, likely more than 5 times the size of our Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass, or a butterfly. If you decided to lump together all the known asteroids in the solar system, their total mass wouldn't exceed even 10% of the mass of our Moon. A cloud of water vapor is floating in space. It surrounds a supermassive black hole 12 billion light-years away from Earth. The cloud contains 140 trillion times the entire volume of water on our planet. Astronomers think this water cloud appeared just 1.6 billion years later than the universe itself. The densest objects in space are neutron stars. They're the size of a small city, yet their mass is about 1.4 times the mass of our Sun. A single teaspoon of neutron star material would weigh 1 billion tons. And a neutron star's gravity is 2 billion times stronger than the gravity of our planet. In 1993, the Galileo probe was traveling past a miniature asteroid. It was no more than 20 miles across, and still, the tiny thing had a 1-mile-wide moon. Astronomers have discovered tons of moons orbiting minor planets in the solar system since then. We live inside the Sun. The star's atmosphere stretches way beyond its visible surface, and our planet is well within its reach. That's how the gust of the solar wind creates such a breathtaking phenomenon as the northern and southern lights.
In the heart of the galaxy, there lies a mysterious object, the likes of which no astronomer has ever seen. It streaks across the sky like a shooting star on caffeine. So, what is this mysterious blob? And how is it related to the black hole in the center of our galaxy? Let's find out. This thing is called X7. It's the mysterious blob that's been hanging around our galaxy's supermassive black hole for decades. Some even say it's been lurking around there for, like, hundreds of years. We know a few things about X7. For example, it weighs around 50 times as much as Earth. It may sound like a lot if you're an Earthling, but in space, that's like a tiny drop in the ocean. X7 is also moving pretty fast, at speeds of up to 700 miles per second. That's faster than you trying to catch the last slice of pizza before your roommate gets to it. But what in the world is this thing? A magic star we've never seen before? An extraterrestrial spaceship? Well, there are some theories connected to the blob's future tragic fate. Unfortunately, X7's days are numbered. Right now, it's on a 170-year-long elliptical orbit around the supermassive black hole at the center of the Milky Way. But it's not going to make it that far. Each year, it's spiraling closer and closer to the black hole. In just a few years, it will become spaghettified. Yes, that's a real scientific term. And finally get sucked in, never to be seen again. There are supermassive black holes in the centers of all galaxies, including our very own Milky Way. These black holes are so massive that they warp space-time, causing nearby stars to orbit around them at incredible speeds. They serve as cosmic vacuum cleaners that suck in anything and everything that comes close enough. The black hole in our galaxy is called the Sagittarius A star. Sounds like the name of a fancy Hollywood celebrity, doesn't it? But this celestial object is far more impressive than any mere mortal. It's about 4 million times more massive than our Sun, which means it could probably eat our entire solar system for breakfast. But don't worry, these black holes may seem really scary, but in reality, they're too small to compete with an entire galaxy. They'll just suck in a couple of the nearest stars, and that's all. Also, Sagittarius A star doesn't seem to have a very good appetite. It's been observed to be pretty quiet lately, which is good news for us. But even if it were super greedy, it wouldn't pose any threat to us. This black hole is over 26,000 light-years away. From Earth, we can see it in the Sagittarius constellation. In 2022, the Event Horizon Telescope collaboration released the first ever image of Sagittarius A star. It took years of collaboration and technology to capture this stunning image. And this is our second photo of a black hole in history. The first one was released in 2019, and it showed the supermassive black hole called M87 star. Yes, they both have star in their names. Don't try to make it make sense. Anyway, you may remember this photo as the first ever image of a black hole ever. It went crazy viral across the internet. And this black hole, M87 star, located in the Messier 87 galaxy, is way scarier than Sagittarius A star. You thought 4 million solar masses is impressive? Then how about 2.5 billion solar masses? M87 is a real monster. It's also known for its powerful jets of plasma, which are so energetic that they extend thousands of light years from the black hole's center. If M87 were a superhero, it would be Iron Man, with his repulsor beams on full blast. Now, technically, you can't take a photo of a black hole itself, since it's, well, black. No light can escape its grasp. But the glowing orange ring in this photo shows the matter surrounding Sagittarius A star. It's called the accretion disk, a swirling disk of hot gas that spirals the center, heating up to millions of degrees in the process. It's like a giant fiery vortex, but with no escape. And the shadow in the center indicates the black hole itself. Inside that shadow, there's an event horizon. The event horizon is the boundary around the black hole, beyond which nothing, not even light, can escape its gravitational pull. It's the point of no return, where the gravitational force is so strong that even the fastest object in the universe, light, can't escape. Once you cross the event horizon, you're doomed to fall toward the center of the black hole, where the laws of physics as we know them break down. And this is exactly the fate that awaits our unfortunate X7. Right now, the pure blob is getting stretched and yanked by powerful tidal forces. By the way, before it meets its untimely demise, X7 is expected to put on a bit of a show. Its closest approach to the black hole, called periastron, is projected to happen in 2036. And when it finally gets torn apart by the Sagittarius A star's gravitational forces, there may be some cool fireworks to see. But this is not the most important thing. The funny part is, X7's future end may help us finally understand what the heck even is this thing. A team of scientists have been studying how a strange blob orbits the black hole. And that's when they discovered that X7 has stretched to almost twice its initial length. And what does that mean? Well, it suggests that X7 is most likely made of debris ejected during a recent collision between two stars. Yep, you heard that right, a space car crash. Imagine this. Two stars fall in love and start circling each other for many years. After that, they finally merge together. At this moment, they eject tons of gas and dust. And perhaps this cosmic dance created our blob baby, X7. It's basically like the crumbs left on the table after a giant space feast. Something like this is actually pretty common, especially around black holes. It's like a galactic fender bender that sends debris flying everywhere. Actually, the universe is full of mystery blobs. They're called the G objects. No, they're not the G-men from Men in Black, but they're just as mysterious and elusive. These guys have been puzzling astronomers for more than 20 years. They look like gas clouds, but behave like stars. It's like they can't decide whether they want to be a cloud or a star. Come on, guys, make up your mind. G objects stretch out at the closest point to the central black hole, but emerge intact, like a rubber band that stretches but doesn't break. Scientists think that they're the stars that have merged together into one. And while doing that, they also produce a huge cloud of gas that hides the result from view. Kinda like when you're wearing a bulky sweater, so that no one knows that you've put on a few extra pounds. And then a study published in 2021 found that one of these objects, G2, was actually a molecular cloud concealing 3 baby stars. Talk about a plot twist. But X7 is the black sheep of the strange blob family. It's significantly different from the G objects, like the weird cousin you see once a year at family gatherings. Its evolution has been more dramatic. Also, it's not being held together by a mass lurking in its center. So what is it being held together by? Pixie dust? Magic? We need answers! That's why scientists believe that X7 isn't a G object itself, but debris left from it. Or maybe not. We have no idea. The possibilities are endless, and that's what makes astronomy so exciting. So let's keep our eyes on the skies and see what other strange objects are out there. Who knows? maybe we'll discover another mystery blob. And this time, it's going to be a spaceship. Now that would be awesome.
Stellar mass and intermediate mass black holes form when huge stars can't support nuclear fusion anymore and collapse, unable to withstand their own gravity. But it's not so clear with supermassive black holes. The mechanism of their formation is still unknown, since there seem to be no stars large enough to directly collapse into such a giant black hole. Nearly every large galaxy has a supermassive black hole at its center, and our Milky Way isn't an exception. We've got Sagittarius A, which is pronounced Sagittarius A star. This space monster is mostly dormant and rarely wakes up to munch on gas and dust, and still, its mass is millions of times that of the Sun. To be precise, almost 4.5 million times. There are still lots of mysteries surrounding this black hole, but one of the most recent discoveries can also be the most exciting. But we'll get there later. Right now, imagine a distance of 14.6 million miles. It's like about 61 distances from Earth to the Moon. That's the diameter of our supermassive black hole. Of course, it will look tiny compared to the Milky Way itself, which is 100,000 light-years wide and 1,000 light-years thick. But it's still impressive. At the same time, Sagittarius A is dwarfed by a disk of gas surrounding it. It extends for a whopping 5 to 30 light-years and occasionally feeds the black hole. When it happens, faint flashes of X-rays are produced. The disk, known as the accretion disk, is also responsible for X-ray emissions triggered by friction. This friction can make the temperatures inside the disk go as high as 18 million degrees F. And now the coolest part. The supermassive black hole at the heart of our galaxy is not just spinning, it's doing so at almost maximum speed, dragging everything close to it along for the ride. Scientists have calculated the rotational speed of Sagittarius A with the help of NASA's Chandra X-ray Observatory. Normally, the spin speed of a black hole is given a value from 0 to 1, with 1 being the highest rotational speed. Speaking of our supermassive black hole, its rotational speed is between 0.84 and 0.96. That's close to the top limit, defined by a black hole's width. Now, the spin of a black hole is very different from that of other space bodies. Solid objects, like planets, moons, or asteroids, have physical surfaces. But black holes are regions of space-time surrounded by an outer, non-physical surface. This surface is called the event horizon, and even light can't escape beyond it. The rotation of a planet or a star depends on the distribution of its mass. At the same time, the rotation of a black hole is governed by its angular momentum. The extreme gravitational forces next to a black hole cause space-time to become slightly curved and twisted. It forms what we know as the ergosphere. This notion is unique to black holes and never occurs around relatively solid space bodies like planets or stars. In other words, when black holes spin, they twist up the very fabric of space-time, dragging along the ergosphere and everything it contains. This phenomenon is known as frame dragging. Come to think of it, the name does make sense. Thanks to this dragging, we can observe weird visual effects around black holes. The theoretical maximum speed of a black hole is determined by how it grows after feeding on matter. As something falls into a black hole, it increases its spin. Plus, we should take into consideration the mass of a black hole. The more massive it is, the higher its gravitational pull is. And this makes it more challenging to increase the speed of the spin. Let me illustrate this idea. Our relatively not-so-heavy supermassive black hole, whose mass is equivalent to around 4.5 million suns, has a spin between 0.84 and 0.96, which is very fast. At the same time, a much heavier supermassive black hole at the heart of galaxy M87, which has a mass of 6.5 billion suns, is spinning just as fast, between 0.89 and 0.91. The solution to this mystery? This black hole is also feeding very rapidly, which allows it to increase its speed.
How about going deep, deep into the past? To the times before humans existed, before the infamous asteroid hit Earth, wiping off 3/4 of life forms on the planet, even before the sun ignited or galaxies appeared in the darkness of the cosmos. So, before light could even shine, there was the Big Bang. It happened 13.8 billion years ago. But what was before that? Some scientists are sure that there was no before. Time started ticking as soon as the Big Bang occurred. We're unlikely to ever figure out what reality was like before that, if any. This is beyond human understanding, but there are those who disagree. Some unconventional scientists theorize that just a moment before the Big Bang, all the energy and mass of the nascent universe could be compacted into an insanely dense but still finite speck. Let's imagine it as a seed of a new universe. And this seed, a chunk of essential material, compressed and hidden in a protective shell, was created nowhere else but inside a black hole. Black holes spin incredibly fast, probably close to the speed of light. Such a spin can give the tightly compacted seed a ginormous amount of torsion. So the seed isn't just tiny and extra heavy, it's also compressed and twisted, which means that it can suddenly unspring with a big bang. Now, let's say you add up the energy and mass of all the particles the visible universe contains. And then you try to figure out the answer to the following question. How big could the event horizon of a black hole with the same mass be? The event horizon is the point of no return. Once you cross this invisible line, there's no way back, even for light. But let's get back to our question. Shockingly, such an event horizon would be very close in size to the actual horizon of the observable universe. There's also this idea that became well known thanks to Stephen Hawking. According to it, every time a black hole appears in our universe, it probably gives rise to a baby universe. But you would only be able to visit such a universe if you crossed the event horizon and plunged inside the black hole. And as you know, once you did it, you wouldn't be able to return. In other words, right now, we might be living in a baby universe. But if some outsider is observing us at the moment, our world looks to them like a regular black hole. So in short, there could be a very old mother universe that forged a seed inside a black hole. This seed had its big bounce all those billions of years ago, and as a result, our universe came into existence. But even though since then it has kept growing and expanding, we might still be hidden behind the event horizon of our home black hole. There's also another idea. According to string theory, there's a multiverse of universes. Imagine our universe as a soap bubble. This bubble keeps expanding, and we live on its surface. String theory claims that our bubble isn't unique. There might be other bubbles out there, and all these bubbles move around, collide, sprout, or bud baby bubbles. In short, live their life. If we follow this theory, we might suppose that black holes are one-way doors between universes. And if you accidentally tumbled down the black hole in our home Milky Way galaxy, you'd end up in another universe. Or rather, not you, but what's left of you after falling through the insane weirdness of the black hole. In this case, this second universe wouldn't be inside ours. It would exist separately, and the black hole would merely be the link connecting them, like a shared route between two aspen trees. Whatever the truth, the danger is still there, lurking in the shadows. What if the black hole we live in decides to collapse? What if it pulls us deeper inside? Or if our world is just a bubble among trillions of other bubbles? What if it bursts one day?
You might think falling into a black hole is as easy as falling into a giant pit. But boy, is it a whole different ballgame. To actually fall into a black hole, you would need some incredible luck and a dash of wizardry. Moreover, if you were watching something fall into a black hole, you wouldn't even see it. Why? Well, let's try to understand the magic of physics. Falling into a black hole is really tricky. First of all, to even have a chance of doing this, you would need to aim perfectly and start your journey from very far away. It's like trying to hit a tiny target from a long distance. That's because black holes exist within galaxies, which are filled with other objects like stars, planets, and gas clouds. These objects have their own gravitational forces that can influence the path you need to take. It's like you have to carefully navigate through the room, avoiding bumping into others or getting pulled off course by their movements. In a similar way, when falling into a black hole, you need to navigate through the influences of other celestial objects. As you get closer, things get even more complicated. Making even the tiniest change in direction would require a tremendous amount of energy that you wouldn't be able to generate. It's like trying to steer a spaceship with no fuel left. This is because the black hole's gravitational pull is immensely strong. Once you pass the point called the event horizon, there's no coming back. You wouldn't be able to control anything. Now, even if you somehow manage to get on the right path and avoid all the obstacles, there's still a dangerous situation waiting for you. The intense heat and energy around the black hole, called plasma, would fry you as you get closer. So, you would need some impossibly strong protection to get even close to it. But not only is it nearly impossible to fall into a black hole, it's also impossible to see someone falling in it. Why? Let's find out. Imagine you're standing far away from a black hole, watching something getting closer and closer to the event horizon. As this thing, let's say it's a spaceship, falls into the black hole, two very strange things start happening. First, the color of the spaceship will change. You see, the gravity near a black hole is incredibly strong, much stronger than anything we experience here on Earth. This intense gravity affects everything around it, including light. Now, light has this fascinating property where it carries energy. But when light gets close to a black hole, the powerful gravitational pull starts sapping away its energy, kinda like stealing it, making light weaker. And you know how when you look at a beautiful sunset, the sun appears to be this warm, reddish-orange color? Well, that's because when sunlight travels through our atmosphere, it scatters and loses some of its higher energy bluish colors, leaving behind the redder ones. So when light loses energy, it tends to shift towards the red end of the color spectrum. The same thing happens near a black hole. The light from the spaceship loses energy due to the black hole's strong gravity. So, the spaceship, which initially had its own color, starts looking redder and redder as it gets closer to the black hole. It's as if the black hole is casting its magical spell, changing the color of the spaceship itself. The second weird thing is related to time. According to a theory of general relativity, gravity can mess around with time itself. And it works in a very strange way, because none of you, not you, not people on board a spaceship, will feel this change. For you, an observer in this scenario, time is flowing just like it always does. You're just sitting there, sipping your space lemonade and watching the spaceship's journey. For people on a spaceship, things are the same. Their watch ticks away at a regular pace, and they go about their day as usual. But, objectively, for you, it would be like watching a spaceship fall in slow motion. It will seem to you that it's been falling into a black hole for weeks or even years. You might turn 80 and the spaceship is still out there. Crazy, right? Now, if time slows down for the spaceship, it means the light it emits also slows down. So, imagine someone on that spaceship flicking a flashlight on and off. But because time is moving so slowly, the light coming from the flashlight also moves in slow motion. It takes ages for each burst of light to reach your eyes. You'll be watching a spaceship as if you're watching a video in super slow motion. And when light takes longer to reach your eyes, it becomes weaker and dimmer, just like a fading star. So, as the spaceship gets closer and closer to the black hole's event horizon, not only does it start looking redder, but it also appears dimmer. So it becomes harder and harder to see the spaceship as it gets closer to the black hole. It slowly fades away, like a disappearing act on the grandest stage of the universe. Pretty mind-boggling, isn't it? But that's all about you, the observer. And how are people on board doing? What do you actually experience when you fall into a black hole? As you get closer to the black hole, something really weird starts happening. The gravity near the black hole is so powerful that it stretches and warps everything around it. So the difference in gravitational pull between your head and feet becomes significant. This difference creates a tidal force, which stretches your body like a long, thin shape. It's a process that's scientifically called spaghettification. Essentially, you would be stretched into a human noodle. Being turned into spaghetti might sound fun for a pasta lover, but it's definitely not so great for an astronaut. Meanwhile, colors around you begin to warp and distort, creating a dazzling light show. It's like riding a roller coaster through a rainbow tunnel. Twists and turns, flashes and sparks. It's an exhilarating, mind-bending experience. And then, what happens to you depends on the type of black hole. First, we have classical black holes. These are black holes that exist forever. If you fall into this black hole, it would take an incredibly long time to reach the center. The center would keep getting closer and closer, but you would need an almost infinite amount of time to reach it. So it would feel like your journey would never end. And then we have evaporating black holes. These black holes can evaporate over time due to a process called Hawking radiation. It's just like the ice cubes melting away. These black holes have a limited lifespan, and it's basically impossible to fall into one of them. As you approach the evaporating black hole, you find yourself hovering near its edge, the event horizon. It's like being stuck at the entrance of a super cool amusement park. But guess what? This amusement park is shrinking. The black hole is evaporating, and as it does, the event horizon gets smaller and smaller. So you stay right at the edge, tracking its every move, but you will forever stay in this event horizon without ever crossing it. But remember, once you pass the point of no return, there's no way back. You're on a one-way ticket to the mysterious heart of the black hole, the singularity. At the singularity, everything goes bonkers. Our current understanding of physics goes haywire, so it's a bit like entering a magic show. What happens once you reach the singularity? Is there anything on the other side of a black hole? We have no idea. It's a big mystery for us, but maybe we'll figure this out someday. So, my friend, it's best to admire black holes from a safe distance and let your imagination soar with the incredible wonders they hold. Just remember to keep your pasta on your plate and not near these cosmic spaghetti makers.